Hi guys, my name is Ranjit. I'm here to talk about my final project, identify homonyms in a large corpus of text and generate different word to vectors for each. Um, the project has been created in a Jupyter notebook. I'll briefly go over what tools I've used to solve this problem, and finally what the next steps are. The problem statement, as I mentioned earlier, is identify homonyms in a large corpus of text, generate different word to vectors for each. I've used NLTK as the source for the data. I've used BERT for the vectorization. The assumptions I've made is I'm using a restrictive definition of a homonym, namely words that share the same spelling but have different meanings. There are various drawbacks and challenges with trying to solve this kind of a problem. It's not an easy problem to solve. There are various tools available. Not all of them are suitable for this. BERT probably comes the closest to solving it, but is not a perfect solution either. In this particular case, I've used PyTorch implementation. Moving on, the corpus of text that I've used is sourced from NLTK Gutenberg corpus, and the particular text that I've chosen is the Chesterton-Brown text. The name of the book is The Wisdom of the Father of Father Brown by author G.K. Chesterton. The model I've used in this particular case, before I dive into that, let me briefly go over word2vec. Word2vec is a group of models that can be used to produce word embeddings. It does a good job of identifying degrees of similarities between words, but it doesn't take into account the context of the word, or rather the sentence that the word is embedded in. So in this particular case, it's not a good fit to solve this problem. BERT is what I've used. It's a new model that was recently open sourced by Google. It uses bidirectional training of the transformer, a popular attention model. As opposed to directional models which read text input sequentially, the transformer encoder reads the entire sequence and is therefore considered bidirectional. This allows the model to learn the context of the word based on its surroundings. As an example of a homonym, two sentences: I went to a store, and the second sentence is I need to store this item. In both these sentences, we see the usage of store. They mean two different things. Word2vector would have returned the same vector for the word store, but BERT would provide two different vectors for this, which can therefore be used to identify if these are homonyms. The assessment of what steps I took to actually implement this. To identify homonyms in the book, I basically identified duplicate words, processed the sentence that these words were embedded in, passed them to BERT, and computed their vectors. And then I used the cosine similarity between words to compare these two vectors to see what the difference is. If the similarity was less than 0.5, I have assumed that this word could be a homonym. Next steps. Baidu has released a new model called ERNIE. ERNIE stands for Enhanced Representation Through Knowledge Integration and relies on a transformer encoder. Next step would be to read up on this new model, see how it works, and try to use it for this exact problem and see if I get better results. Thanks for your time, guys. Have a good day.